This machine weighs 150 tons, costs around $400 million, and exactly one company on Earth sells it. NVIDIA depends on it. So do Google, Amazon, and Microsoft, and every other name fighting the AI chip war. None of them can buy their way around it. And this July, the newest version of it went to work for the one company nobody picked to be first. To see why, stop scoring this war like a product race and score it like a supply chain. 3 layers stacked. The top layer is the fight everyone can see. NVIDIA's Blackwell accelerators earned it over $40 billion of data center revenue in a single quarter. AMD is chasing with its Instinct line. And NVIDIA's biggest customers are building escape routes. Google's Ironwood TPU, Amazon's Trainium 3, Microsoft's Maya 200, launched in January to run OpenAI models on Azure. But line those rivals up and read the fine print, because underneath, they are the same purchase order. Microsoft says outright that Maya 200 is built on TSMC's 3nm process. Amazon's chip? TSMC. Google's? TSMC. NVIDIA and AMD? TSMC. Even Apple, whose laptop chips have nothing to do with data centers, buys the same leading-edge capacity for its M series. Building an NVIDIA alternative does not get a company out of the supply chain. It adds one more name to the line outside the same foundry in Taiwan. That foundry makes the overwhelming majority of the world's most advanced outsourced chips. Estimates put it around 90% of leading-edge capacity. Last quarter, it billed $40 billion at a 67% gross margin, pricing that only exists when your customers have nowhere else to go. The United States is buying insurance. TSMC's Arizona site has 1 fab in production and 2 more behind it. But the newest processes stay in Taiwan for years first. Arizona's next fab is slated for 2027. Until then, the line forms in Taiwan. And here is the twist inside the twist. Right now, the tightest gate is not even the wafer. A modern AI accelerator is really a package. The compute die sits in the middle. Around it, towers of stacked memory chips called HBM, all fused onto a silicon baseplate so data can move at terabytes per second. TSMC calls the assembly process CoWoS, and it is its own scarce factory line. Miss a packaging slot, or miss your memory stacks, and a finished wafer is not a product. It is inventory. Investor Clark Tang filmed a physical model of one of these packages at ASE, the packaging house. The memory towers lift off, the logic die lifts out, and you can hold the whole sandwich in your hands. Keep that picture because it explains the strangest story of this year. TSMC's own boss has described advanced packaging capacity as essentially sold out through 2026. Supply chain trackers report NVIDIA reserved more than half of it in advance. And Google reportedly had to cut its 2026 TPU build target from 4 million units to 3 million because it could not get enough packaging. Even Google waits in the line NVIDIA paid to skip. Memory is just as narrow. SK Hynix alone ships over half the world's HBM, and the handful of companies that make it are effectively pre-sold through the year. Now go one layer further down, because TSMC has a supplier it cannot replace either. Printing features a few nanometers wide takes extreme ultraviolet light, and the only industrial way to make that light sounds like science fiction. Fire a laser at droplets of molten tin, tens of thousands of times per second, vaporize each droplet into plasma, and collect the glow with the smoothest mirrors ever manufactured. One company on Earth sells production machines that can do this. ASML in the Netherlands. Not the market leader, the only seller. Its newest generation is called High NA. That is the 150-ton, $400 million machine this video opened on. And July's surprise is who put it to work first. Not TSMC, Intel. On July 15th, ASML announced that a slice of Intel's new Panther Lake laptop processors is now shipping in high volume with selected layers printed on high NA machines, at yields matching the older platform. It is a narrow first, a few layers, one product family, but it proves the deepest layer of the stack does not automatically serve the incumbent. TSMC looked at the same machine and passed for now, betting it can squeeze its existing fleet until the price makes sense. If you still doubt the stack is the real map of this war, look where the weapons point. The export controls aimed at China do not ban GPU brands. They cut layers. EUV machines. China has never been allowed to buy one. Advanced DUV machines, their servicing, even the software license keys that keep them running. Controlled. High bandwidth memory, restricted since December 2024. Advanced foundry service for Chinese chip designers, fenced off. China's workaround is to push older machines through multiple exposure passes. And it works. Its top foundry has produced 7nm class chips that way. But every extra pass adds cost, time, and defects. And that is the point. The controls will not stop Chinese chip making. They are built to keep its leading edge years behind. So score the war both ways, because there are two scoreboards. On the money scoreboard, NVIDIA is winning by a distance, worth nearly $5 trillion, margins above 70%, and a software moat called CUDA that keeps customers paying even while they design their escape chips. On the permission scoreboard, the power runs the other way. NVIDIA ships what TSMC can package. TSMC prints what ASML's machines allow. SK Hynix decides how much memory sits next to anyone's die, and 3 governments hold switches that can cut any layer off from an entire country. Between now and 2028, watch 3 things: whether Intel's high NA head start attracts real foundry customers, whether TSMC's packaging expansion finally catches up with demand, and how far China's workarounds creep. The names on the chips are the faces of this war. The layers underneath decide who gets to fight, which is why the most important machine in AI never runs a single line of code.